Now, when we've got our rubber made, we now need to make it into a rubber product. So what we have here is some raw rubber. This is actually from the tropical rubber tree. This one's from a different alternative source. And we have some other rubber that's over here. Now, this, you can see, is very tough looking rubber. We have to mix it. So this is like part of the dough in your kitchen. We have to stir this up. But how can you stir something that's this tough? Well, the first thing is you have to cut it up into small pieces. And then you mix in your ingredients, which would be your sulfur for cross-linking, accelerators, antioxidants, processing oils, things like that. And your filler is key to making a reinforced material. Now this is carbon black. So this is the one made from petroleum by spraying and drying. It's a spray-dry process. And this is what makes all rubber things black. Rubber is not black, carbon is black. This is why people think that rubber is black. Okay? Now we've in our group done some very interesting things. This is a filler that you could do a 50% replacement of carbon black with ground up tomato peels and processing tomatoes. And they've been bred so that the one in the bottom of the truck doesn't get squashed by 500 sitting on its head. So it's very tough material, just what you want in a filler. And then our most successful filler is this material. This is actually micro-sized eggshells, which are produced in enormous quantity. We actually use 94 billion eggs a year in the US, and half of them at least are produced at food processing plants. It's a very accessible material. So then what we do, we cut it up, and Tony will show you how we have to cut this material up. These bales of rubber come in 75-pound lumps, which are very heavy. So this one's already had its end cut off, but we use this same thing, whatever size of bale, and so they fit in here. And this is how you cut it. And then we would turn it the other way and cut it up into small chunks. Now Tony has already cut up some waste rubber into small pieces for this demonstration. And he's going to feed those waste rubber into the rubber mixer. And it also adds all sorts of compounding ingredients in a particular order. And there's a big tamper that comes on this that pushes that rubber into the mixing bowl that's at the bottom of this. Now, you saw how hard that rubber was. It takes a tremendous amount of power to mix these ingredients uniformly into the rubber mixture. So this is high shear and high heat. So this is a lot of hard work. Now, we also have power capture software. So this is being pumped out of this machine, and we can tell how much power is needed at any stage of this process to mix this material. So this is what these traces are. This allows us to say, do eggshells reduce or increase power? Or are tomato peels, do they increase or reduce power? We're actually finding that using bio-based fillers as a partial component of the total filler does actually reduce the power. The cost of electricity to power these machines is one of the major costs in a tire factory. So they're very interested in power reduction. Now this batch is almost finished. As we can see, this red line is very flat. This means there's no fluctuations in the power required to keep this blend homogeneous. And this means this is ready for discharge. So Tony is now going to discharge this batch of rubber, and it will come out of the machine, and we will then mill it. Now Cindy has taken the rubber that came out of the mixer and is now putting it on the rubber mill. So this is like going from your mixing bowl to your rolling pin. And so she is going to thoroughly mix and blend and roll out the rubber. And this is what is done in the big tire factories, for example. You'll see this on a much larger scale. As you can see through the top, there's what's called a dam, as the rubber is mixing and above the juncture between the two rollers. And that you can see that the rubber is really mixing very well. Then she'll take it off the rollers and fold it back up again and refeed it. And there's a particular protocol of how many times and in what manner you do this to meet ASTM specifications. When this is finished, she'll pull the whole thing out, keeping track of which direction the roll was in. Then a small piece will be cut out and will be put into the heated press. Now the next stage is to cure the rubber, make a finished rubber piece. So Cindy cut out a small piece of rubber and put it into that stainless steel ASTM specified mold. This goes into the oven. This is a heated press. We put 15 tons of pressure on it, 320 degrees Fahrenheit or 160 degrees centigrade. And we now cook that for about 15 minutes. Right, now this cycle is almost finished, so our rubber is almost completely cooked. When we reach the end of the preset cook time, the press will stop and open all by itself. So your oven door is automatic in this instance. So now Cindy will bring this over and open up the cookie sheet, as you like, the mold, and take out the sample. This is now a finished piece of rubber. We would normally wait at least 24 hours before testing the tensile strength of this.